Hey, welcome to number part 5. How are you going? Getting some skills? Let's have a look around the screen now. I've got a puzzle for you. There are some red numbers and some blue numbers and one black number. What's the difference between all these numbers? Okay, can you see a pattern from your previous work? What can you do with the red ones that you can't do with the blue ones? Or what can you do with the blue ones you can't do with the red ones? What do you think? Study it, pause it, talk to your classmates and see if you can see the difference there. Okay, come on down and let's have a look. And here it is, of course. I wonder if you got this. The blueies are the ones where you can't divide by anything apart from the number itself and 1. So it doesn't have factors. Two numbers multiplied together, to give that number, there are only two factors, itself and 1. It's called a prime number. A first number, if you like. Prime from primus. A first number. Okay, so you can't divide them by anything apart from themselves and 1. All right, is that true? You want to check some of those out? Are they all like that? I wonder, do you think? So have a look through there, and there might be one up there in the blues. You want to check it out? Can you find one up there in the blues which is perhaps not prime? Okay, are there any? Check them out. That's what we're going to do in this presentation now. We're going to try and break down numbers into products of factors and see what they've got in common, and maybe even discover the divisibility laws that way. Okay, and what are the red ones? Well, the red ones are composites, because you can actually have a natural number which will divide into it more than just one, more than itself, and you can write it as a product of factors. Now what we're going to do here is to try to break all numbers down into a product of prime factors. And of course the number in the middle is 1, and 1 is said to be neither prime nor composite. Okay, because the definition of a prime number is it has exactly two distinct factors, 1 in itself. So we're using 1 as a defining number to define what a prime is. And so we're going to just leave that in the middle. It's neither thought of as a prime nor composite. So I hope you've seen those things before. We're going to investigate them in some detail now. So come down and let's have a look at this question. Why might we want to write numbers in terms of prime factors? Well, I think number 1, what do you reckon? It allows you to compare numbers. Okay, compare composite numbers and look for common factors and common multiples. We can also look at whether they can be divided, divisibility rules, like can you divide a number by 3? If we write it as a product of primes, then we should be able to work out that divisibility rule, or whether they are divisible by a certain number. Okay, so that's what we're going to do, is going to break them all down and just see what they have in common, what prime factors they have in common. All right, come down. And there's a couple of ways of doing that. And you should be able to do it both ways. So here we are. Let's take a number, 600. It's a composite number. We want to write as a product of prime factors in index or power form. So one way of doing it is repeated division, similar to what we were doing before, dividing by a bigger and bigger natural number. We're going to modify that a little bit. We'll start dividing by the smallest prime, which is 2, and that goes 300. We'll do it again, goes to 150, do it again, it comes to 75. Now 75 is no longer divisible by 2, so we move to the next prime. Coming down here, move our division to the next prime. So we are going to now divide by, the next prime is 3. 3s and 75 go 25. 3s don't go into 25, so we're going to keep moving to the next prime. The next prime is 5. 5s into 25 go 5, and then we'll do it again, and we get 1. So we're at the end when we get 1. Okay, so what have we got? Let's add them up. There's 1, 2, 3 2s. Okay, then a 3, and then a 5 and a 5. So we would say that is 2 cubed by 3 by 5 squared. Can you see, writing 600 in this way, we can see it is divisible by 2. and by 3 and by 5, because that will divide into each of those prime factors, each of those numbers. Okay, the other way is a factor tree. Start off at 600 and do any pair of factors. Any factor pair. Doesn't have to be prime or anything you can think of. When you get there, you then keep breaking it down. So 6 is 2 by 3 and they are both prime, so you go no further. 100, what can you think of? 50 times 2 or 4 times 25? Doesn't matter which one, any factor pair, and you keep breaking it. So 4 is 2 2s. Can you go any further? No, they're both prime. 25 is 5 5s. Can you go any bit further? No, they're both prime. So you get the idea? It's less sort of systematic, but it will get to the end point as well. So you can use either. I want you to be able to do both of these. I think both of them have value. Both methods you need to do here. All right. Okay, well, let's list it now. How many 2s? That one, and that one. So pick them out, or you could just list them through here, like the book has done here. Again, screen clippings here are from Hayes and Harris Publications, so it'd be a good idea to have that book handy. So have a look. Okay, so then you've got a 3 and 2 5s. It's going to come to the same answer, of course. Slightly different method. A system where you move your division through a growing series of primes versus taking any factor and keeping the breakdown going until you reach a prime number at the end. Okay, I think it's your turn. You want to have a go? Let's have a look now. We need this tool for later on when we're going to go back to highest common factor and lowest common multiple and see what happens there. So let's have a look now at these problems. So I'm going to leave you just to have a go there, and here's breaking the numbers down as primes. Here's a little puzzle question for you. You need to see the pattern, look for a pattern, and then predict what 3 to the 50 would do. Hey, we don't want to do 3 to the 50. Can we work it out even without a calculator? I think that's an exciting little problem. All right, and similar one in 7. So, are you ready? Pause the presentation, have a go. I'm going to show you the answers now. There are our answers right there. And I think the last couple here, little tricky ones where you're looking for patterns and stuff. See how you went there. Okay, talk to your teacher, talk to your classmates about the patterns you're looking at. Because what we're trying to do is get up close and personal with number in these presentations. I think there's only a couple more, and that will give you your tools to get into maths. Get up close and personal with our tools here, the number forms that we're going to be using. All right, well, I hope you enjoy yourself. I'll catch you in the next presentation. Cheers for now.